Light, reflection and refraction. Part 3. Let us refresh the terms that is used in spherical mirrors. As you can see, pole is the center of mirror's surface, which is denoted by P. The center of curvature is denoted by the letter C. The distance between the pole and center of curvature is radius of curvature. Focus F is the point on the principle where the reflected rays meet or appear to meet. Focal length is the distance between pole and the principal focus. Then there is object distance, object height, image height, etc. Magnification in mirrors. Magnification tells us how much bigger or smaller the image is compared to the object. It also indicates whether the image is upright or inverted. Magnification is the ratio of the height of image to the height of object, and also equals to minus of image distance from the mirror divided by object distance from the mirror. The formula is m equals to hi divided by ho, which is also equal to minus of v divided by u. If the magnification is greater than 1, the image is magnified. If the magnification is 1, the image is of same size. If magnification is less than 1, the image is diminished or smaller in size. If m is positive, the image is upright and virtual. If m is negative, the image is inverted and real. Another formula that is used for calculations is the mirror formula. The mirror formula gives the relationship between the object distance, image distance, and focal length of a spherical mirror. The formula is 1 by f is equal to 1 by v plus 1 by u, where f is focal length, u is object distance, and v is image distance. We have to be aware of the sign convention while doing problems. For example, the distance measured in the direction of incident light is taken as positive. The distance measured opposite to incident light is taken as negative. Heights measured upward is positive. Heights measured downwards is negative. All distances are measured from the pole of the mirror. Also, for a concave mirror the focal length is negative. For a convex mirror the focal length is positive. Let's do a problem. A spherical mirror forms diminished virtual image of magnification 1 by 3. Focal length is 18 centimeters. Find the distance of the object. We know the formula for magnification. M equals minus V by U. Using that we get V as minus U by 3. Now substituting the value of V in the mirror formula, we get 1 by 18 is equal to minus 2 by U. So U equals minus 36, which is the distance of the object.
Refraction.
Refraction is the bending of light when it passes from one medium to another, for example, from air to water or air to glass. When a pencil is placed in a glass of water, it looks bent or broken at the surface. That's because of refraction. Another example is the bending of colors in white light when it is passed through a prism.
Let's have a close look. When a ray of light passes from air to water, there is a change in direction of light, or we can say, deviation, when it enters water. In this example we see the refraction from rarer to denser medium. Air is rarer medium and water is denser medium. The angle at which the light deviates is equal to angle of incidence minus the angle of refraction. If refraction is from denser to rarer medium, the angle of deviation is angle of refraction minus angle of incidence.
Refractive index. Refractive index and the speed of light. Refractive index of a medium tells us how much the speed of light slows down in that medium compared to the speed of light in vacuum. Formula is n equal to c divided by v, where c is speed of light in vacuum, v is speed of light in the medium. Refractive index also depends on the nature of the medium, wavelength and the color of light. If there are two medium, for example air and water, the refractive index of medium 1 with respect to medium 2 is speed of light in medium 2 divided by speed of light in medium 1. Snell's law of refraction. Let us assume that light starts from a medium of refractive index n1 and then undergoes refraction into another medium of refractive index n2. If I is the angle of incidence and r stands for angle of refraction, then I and r are related by the formula n1 sin I equals n2 sin r. Or we can write it as sin I by sin r is equal to n2 by n1, which is the Snell's law. Let's do a simple problem. Given the refractive index of air as 1, Refractive index of glass is 1.5. The angle of incidence in air is 30 degrees. We are asked to find the sine of angle of refraction. So using Snell's law, we have n1 sine I is equal to n2 sine r. Substituting the given values, we get sine r is equal to 0.33. Video by Anand Mohandas.